This is just going to be a general discussion on momentum, what we've covered in momentum. Hopefully, if you've been absent a few days, this can help you get caught up. So, momentum is equal to mass times velocity, all right? Or mass times speed if there is no direction. The symbol for momentum is this P, and the reason for that, just if you're curious, is it's Latin. It's from a Latin word, I think petare or something like that. It means to go forward. Momentum is essentially just a measure of a combination of the mass of the object and the speed that it's going. A couple of important things to note is that it's not necessarily that a bigger object will have a bigger momentum. So a bigger mass does not necessarily equal a bigger momentum. It can, but it doesn't have to. And it's not that necessarily a bigger speed equals a bigger momentum. The important thing is that it's the two of them together. And so, for instance, a bullet could have a larger momentum than a baseball, right? If the bullet were traveling really fast and the baseball were traveling really slow, despite the fact that the baseball is way more massive, the bullet could have more velocity, a bigger V, and if the baseball has a really small V, then the baseball would have less momentum. All right? So those are some of the important things about momentum. Another important thing about momentum is that it has to have a velocity. So if there's no velocity, there's no momentum. All right? No velocity, no momentum. Okay, so these are the basics. P is equal to mv. That's your formula. And it's equal to mass times velocity. All right? Fairly simple calculation. For instance, if something had a mass of 50 kilograms and was going 2 meters per second, its momentum would be 100, and the unit for this is a kilogram times meter per second. All right? If you can't remember that because it's confusing, just write units or something. All right? So there you go. That's momentum basics. It does get harder, however, so we need to deal with elastic collisions. The deal with momentum is that it's super, super easy to do the math. It's hard to figure out where or what things are in the problem. So if you can identify in the problem what type of collision it is, you should be able to run back to your notes and then plug it in. So an elastic collision is when you have two objects that are separated at the beginning and then separated at the end. Now I generally use this to indicate where the collision or the event happened, where they were hitting each other. Well, if I could write, sorry. Okay, so this is where the collision occurs. So let's say that this ball is going this way, and this ball has a velocity of 0, and then after the collision this ball has a velocity of 0, and this ball keeps going forward. So for an elastic collision, essentially what you're going to need to do for the formula is you need to remember that momentum initial has to equal momentum final. Alright? So you ought to remember momentum initial equals momentum final. And so the momentum on this side has to equal the momentum on this side. Well, how do we calculate the momentum initially? Well, we have to add up the two momentums of both of these objects, okay? So we need to take the momentum of this guy, so the momentum of object 1 initially, plus the momentum of this guy, the momentum of object 2 initially, and set that equal to the momentum of object 1 finally, plus the momentum of object 2 finally. And if you remember, the formulas for momentum was this. Momentum equals mv. So the momentum for object 1 initially will be the mass of object 1 times the velocity of object 1 initially, plus momentum of object 2, m2 v2i, equals the momentum of object 1 finally, plus the momentum of object 2 finally. Whoops, sorry. m2v2f. Alright, so this would be your final formula. And if you know that it's an elastic collision, you should be able to draw this picture, and then after that, figure out the formula. Okay? If momentum is conserved, if it says that, this has to be true. A couple of things to be careful on. If the objects are going in opposite directions, one of these has to be negative and one of them has to be positive. So one of the velocities would need to be negative and one of the velocities would need to be positive. You would still add them in the problem like this, but you would just plug in, let's say that this guy started off going this way at, I don't know, let's say negative 3 meters per second, right? He was going that way at 3 meters per second. Well, what you would do is you would just plug in right here, you would plug it in as negative 3. And you would keep the plus sign, the negative 3 would go out, and it would eventually subtract. Alright? So this is an elastic collision. Alright? Inelastic collision. So if an elastic collision is where they collide and bounce apart, an inelastic collision is where they collide and stick together. So in an inelastic collision, we have the two objects, alright, and they're going to collide and they're going to stick together, stick to each other. Okay? So let's say that they're going opposite directions in this case, and at the end they're going to end up going this way. All right. So this is how you would draw your problem. If you know, let's just say you're reading along. It says object 1 has a mass of 5 kilograms. In your drawing, I would go ahead and write that in, 5 kilograms. Object 2 has a mass of 3 kilograms. Write that in, and then write it in on the other side as well. So 5 kilograms. 3 kilograms. Let's say if you know the speeds, all right? Let's say that they want to know the question, the final question says how fast were they going after the collision? Well, that's this speed right here, and you're just going to leave it as a v. Okay? And then over here, let's just say that this one was coming in at 3 meters per second this way, and this one was coming in at 5 meters per second this way. All right? So this is how it would look, the drawing would look. Now, you need to remember that momentum initially equals momentum finally, all right? And that to find the momentum initially, we have to add the momentum of object 1 initially plus the momentum of object 2 initially. And to find the momentum finally, look, they're connected to each other. So it's the momentum of both right there, all right? So now we need to figure out what momentum 1 initially is. Well, that's the mass of object 1 times the velocity of object 1 plus the mass of object 2 times the velocity of object 2, and that equals the mass of both of them together, m1 plus m2, because they're stuck together, times v. At this point, we can try plugging in numbers, okay? So m1 is 5, v1 is 5, m2 is 3, v2 you would plug in as negative 3. And that equals 5 plus 3 times that unknown velocity v. And you're looking for v. So you would get 25 minus 9 equals 8v. Or what would that be? 16 equals 8v. And v would equal 2 meters per second afterwards. Notice that it came out positive. Alright? And so that means it's moving to the right. Alright? So that's what that would mean. But this right here will be the same for any inelastic collision that you get. Okay? Next we have an explosion. An explosion is basically the opposite of an inelastic collision. The objects are together initially, and then they're separated in the end. Almost always going opposite directions. In fact, I can't think of a way they wouldn't be going opposite directions. Almost always going opposite directions. But if they are moving to begin with, they would have, that could change, all right? So lots of the time going opposite directions, but if it's going forwards to begin with, it could change, all right? So let's look at how to do this problem, all right? So they're together in the beginning. Momentum initial has to equal momentum final, all right? To begin with, they're together, so you would do m1 plus m2 times their initial speed v. Finally, they're separated, so we need the momentum of this guy, so the momentum of object 1 times the velocity of object 1, plus the momentum of this guy. So we need the mass of object 2 times the velocity of object 2. Alright, the most common problem here that you will get with this setup, the most common problem is the cannon problem. And so we've done the lab over this. So you should have this as an example. If their velocity is initially 0, okay, in that scenario, this would come out to be 0. And so they would have to add together to be 0, which means they would have to cancel each other out. All right, and that's an important thing to remember. Okay, so this is an explosion. Let's look at the last thing we've talked about, and that's an impulse. So an impulse, if you'll remember, is a force applied over a period of time. So a force applied over time. And what this does, so the way you calculate it is an impulse is equal to a force times a time. But an impulse also results in a change in momentum. Remember that the delta means change. So impulse is equal to the change in momentum. Or we could rewrite this as change in momentum equals force times time. And so this is what an impulse is. So a lot of the times you'll see impulse could be friction. For instance, if you push a box and then it slides across the floor, if we have a box and you give it an initial velocity this way and then it slides across the floor for maybe 2 seconds, it slides across the floor, and you want to know what force friction applied, right? If it comes to a stop here, so at the end here, V is equal to 0. If it starts off, say, 5 meters per second, say it had a mass of 5 kilograms. All right. So change in momentum. So the way you find the change in momentum is you do momentum final minus momentum initial, and that should be equal to, in this case, friction times time, should be equal to the force of friction. So the momentum initially, you should know, is 5 times 5, mv, so we get 25, and the momentum finally would be 0 because it has no velocity. And this would be equal to the force, which is friction, times the time, which is 2 seconds. And so we'd get negative 25 equals 2 times friction, divided by 2, and we get negative 12.5 newtons equals the force of friction. And that would be your answer. Okay? That's how you would use an impulse problem. Alright? So I hope this helps. If you have missed a few days, or if you're just utterly lost and confused, hopefully this will help you out and give you a fresh look at this.